Find the number of different arrangements of the 9 letters in the word Andromeda in which no consonant is next to another. Consonants are letters that are not vowels. So we have D, M, N, and R. But remember, we have two Ds in the word. Okay. And the letters A, E, O are consonants. So A, sorry, A, E, O are vowels. So we have two A's in E and O. And together that makes 9 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Okay. So we need to arrange so that no consonant are together. So what we'll do, we'll first arrange the vowels. We have 4 vowels. So 4 factorial arrangements for that. And now these 5 consonants cannot be next to each other. That means they can be here. These are 5 spots and there are 5 consonants. So that will be 5p5. Divided by repetitions, 2 A's are repeating and 2 D's are repeating. Okay, this will give us 720. This is part A. Part B. Find the number of different arrangements of the 9 letters in the word Andromeda in which there is a letter A at each end. Okay, A here and A here. And the and the D's are not together. Okay, so in between we'll have two D's, and apart from that we'll have 1, 2, 3, 4, 5 more alphabets. So if D's cannot be together, first let's ignore those and write those 5 letters. These 5 letters will have 5 factorial arrangements. So 5 factorial. Now the two D's can be here or here or here, or here, or here, or here. So these two Ds have 1, 2, 3, 4, 5, 6 available slots. So times 6P2. Okay. And we will also include these two. These two A's have 2 available slots. So into 2 factorial, divide by the total number of repetitions, which is 2 A's and 2 D's. This gives 1800. Part C. 4 letters are selected at random from the 9 letters in the word Andromeda. Find the probability that this selection contains at least one D and exactly one A. Okay, so this is a question on probability and combinations. So we will consider the two A's as two different A's. So we can take A1 and A2, same with the two Ds, D1 and D2. And other than that, we have E, O, M, N, and R. Okay. Now we need to choose or select 4 alphabets such that at least one D, it has at least one D. So one D needs to be there and exactly one A. So we could have D, A, and some other 2 alphabets, or D, D, A, and some other alphabet. Okay, now let's find all the combinations for that. This D would be 2C1 because there are 2 Ds out of which one got selected. Then the next A will also be 2C1 because there are 2 A's out of which one is selected. And for the remaining 2 slots, we'll have 5C2 because 2 of these 5 will get selected. Okay, this gives us 40. Next is 2C2 for these two. Then 2C1 for this. And then 5C1 for this, which gives us a 10. So that would give us a sum of 50. Now 50 is the favorable outcome. So numerator of the probability, denominator would be all possible outcomes, which would be 9C4. So 50 divided by 9C4 would be 25/63, which is the correct answer.